All right, let's take a look at your next lesson. We're going to do 2-in-1. This is proportions 5-3 and setting up and solving proportions. Heading up to your learning goals today, we're looking at 41 and 42. So testing whether ratios form a proportion. This is really just another way of saying, are they equivalent to each other? And then 42, being able to solve proportions using unit rates and mental math. We're going to do the means and extremes the next lesson. Okay, so go ahead up to your table of contents. You can fill out number for proportions, learning goal 41, and setting up and solving learning goal 42. All right, down we go to the lesson. All right, so your only new vocabulary here is proportion, and I'm going to keep that simple for you. A proportion, we've been setting ratios equal to each other, and this is just a formal way of saying when the ratios are equal to each other, they are proportional. And if they're not equal, then they are not proportional, okay? So we can also say that they form a proportion. There are three ways we already have talked about to create equivalent ratios or to see if they form a proportion. And so we've talked about simplifying or creating equivalent ratios to see if that's possible. We've talked about just creating decimals to see if they're equivalent or proportional, and also using means and extremes or cross-multiplying to see if things are equivalent or proportional. So we're going to continue that today. Normally, you wouldn't have two separate ratios really far apart like this. We would have them right next to each other, and they would say, are these proportional? But you could see both, so it's good for you to see that. Now, just because these are larger fractions, you could tackle these to just see if you can create equivalent fractions. We know we could also just do 10 divided by 14 and 40 divided by 56 to see whether they're equivalent or not. But for this one, because they're all even numbers and things like that, I'm going to go ahead and see what our simplest fractions would be for each of those to see if they are proportional or not. And so let's go ahead and I'm going to just do divided by 2 over 2 for this one, and I get 5/7. Okay, and that's as simplified as I can get. And then the top one, try to find your greatest common factor, I believe would be 8. So I can divide by 8 over 8. And you can see that we actually also get 5/7. And so these are equivalent to each other, which means yes, they are, and here's how you spell proportional, pro, and then P-O-R, and then the shun word, A-L, okay? All right, these next ones, let's go ahead and solve these. We know that you can't just type 1 divided by 8 and then divide by 2 divided by 3. So we need to actually do the division of the fractions, which is multiply by the reciprocal. And so I'm going to do my 1/8 times 3 over 2 for this one. I can't cross-simplify anything, and so I end up with 3/16. And I'm going to put that it's equal to see if these are proportional here. We have our 4/9 times the reciprocal. We can cross-simplify here, so divide by 2 both sides, or top and bottom there. And we end up with 14/27. Okay. Now, just to be sure here, I'm going to do 14 divided by 27. I can see I get 0.5185. And for 3/16 I get something totally different. So these are definitely not proportional. Okay. And so I'm going to say no, not proportional. Okay. On to the next. Okay. This one, they're actually telling us they want us to use the means and extremes theorem. And remember, mathematically, the means and extremes theorem, we know that on this right side, it's 9 divided by 7. So if I want I could multiply by 7 to both sides, okay, and everything will still be equal. And so means and extremes is just saying, if you look at this, 7 times 8, they mathematically figured out, hey, look what you end up actually doing, okay? And so this is just a time saver rather than doing all that other math work, okay? So I always start with this one. And so we have 8 times 7 is 56. Make sure you're putting it equivalent to the other, which is 6 times 9 is 54. And so you can see these are not going to form a proportion, okay? So these are not proportional. So no, not proportional, okay? All right, let's check this one. They want us to do means and extremes. And so we're going to cross multiply here. I'm going to start with this one. So I have 1/5, okay, times 1/7. And so my first one ends up being 1/35. Set it equal to the other. Let's see, we have 2/9 times 9/70. So we definitely want to cross simplify here. These are both even, so I can divide by 2 and get 1. Divide by 2 and get 35. Divide by 9s. And we end up with 1/35, which is nice. So yes, proportional. Okay. All right. So that's it for this page. Let's go ahead to actually solving proportions. So the big twist with this is the proportions they're telling you they are proportional. It's not a question anymore. They're just eliminating one of the numbers, and you need to figure out that missing variable. So later we'll just do what we normally would do, which is isolate the variable, but I do want you to see some other methods as well, okay? So we're going to talk about today using the unit rate and multiplication to solve, or you could just find the equivalent ratio to solve that missing number as well. Means and extremes will be tomorrow, but the means and extremes is really nice for any type of scenario. Go ahead and cross out this section. We're going to address that as we go through other things. I just want to save you some time. So let's look at 3, 4, and 5 here. For number 3, they want us to create equivalent ratios. And so what they're saying is, before you mess with all the cross-multiplying and isolating the variable, which is definitely more work, just see if you can create an equivalent fraction to solve for C. Okay, so I'm going to be looking at this number and saying, okay, can I divide by something over something to create that other fraction? And if you can, then you don't have to do the means and extremes work, okay? Because I already know these are proportional. So C is going to be 5 over C is going to be equivalent to 30 over 42. So I know 5 times 6 is 30. I know C times 6 has to be 42. So if I go backwards, we're talking about dividing instead. And so 30 divided by 6 is 5, and 42 divided by 6 means that C must equal 7. Okay? All right, and then we go over here, the same type of thing. I'm just looking, I know these are equivalent. So 9/4 has to be equivalent to 72 over something. So when I look at this one, I know that times 8 over 8 is what I have to use, because 9 times 8 is 72. So that means 4 times 8 equals 32, and T must be 32. All right, your last one here, we're looking at unit rate and multiplication, because basically this is saying if the cost of 4 light bulbs is $3, if you can understand what the unit rate is for 1 light bulb, then you can quickly multiply to figure out what it would be for 10 light bulbs. Okay, so we're going to just create the unit rate, and we're going to write our $3 on top, okay, because we want to know how much money for 1 light bulb. And so for $3, that's going to get me 4 bulbs. Okay, we want to create that unit rate, so we know that our answer is going to create a 1 bulb answer. And to create unit rates, we know we just do 3 divided by 4, which is 0.75. but that's dollars, so 0.75. So we have 75 cents for one bulb. So if you know how much it is for one bulb, then it's easy to just figure out how much for 10 bulbs, okay? So that's where we would just go over here real quick. I mean, I don't think you would set up a whole nother thing over here. You would probably just take the 75 cents and multiply it by 10 realistically, okay, without using that symbol, and get your answer of how much. But anyway, let's go ahead and take a look and write up this proportion over here. So if we have 75 cents for one bulb, what are we wanting? We're wanting to know what it would be for 10 bulbs. And so now you can use your equivalent ratio strategy and just multiply by 10 over 10. And we then know that it would be $7.50 for 10 bulbs. Okay, that's it for today.